You know, every single time you click a link, send a text, or start streaming a show, a hidden competition kicks off. It's this high-stakes race against the clock, and it happens millions of times a second all over the world. This is the race for less delay. And in this explainer, we're going to see who comes out on top.
It's a fantastic question, isn't it? We always hear that information travels at the speed of light, so why isn't everything just, well, instant? Why do you get that lag in a game or that buffering VR when you're trying to watch a movie?
Well, the answer is that getting your data from point A to point B isn't just about pure raw speed. It's actually a really complex race with all sorts of hurdles and different strategies for winning. And today, we're going to break that race down.
All right, so our main opponent in this race, the one we're all trying to beat, has a pretty simple name: delay. This is the invisible force that every single piece of data on the internet is trying to outrun. So, what is it exactly? Well, network delay is basically the total end-to-end travel time for your data. But it's not just one single thing. It's actually a combination of a bunch of smaller delays that all add up. Think of it like a racetrack with 4 big hurdles. First, your data has to clear transmission delay, which is just the time it takes to get onto the wire. Then there's propagation delay, the actual travel time. After that, it might get stuck in queuing delay, like waiting in line at a busy router. And finally, there's processing delay, while that router figures out where to send it next. Every single millisecond counts. Okay, so to get over these hurdles, networks use 2 fundamentally different strategies. Let's meet our 2 main competitors in this big race against delay. On one side, we have the connection-oriented approach. The best way to think about this is like making a planned phone call. You dial, you wait for the other person to pick up, you both say hello, and only then do you start the real conversation. On the other side is the connection list approach. This one's a lot more like the postal system. You just slap an address on an envelope, drop it in a mailbox, and, well, you hope for the best. Now, before the race really gets going, let's do a little pre-game analysis. Let's look at the stats, because each of these competitors has a unique set of strengths and weaknesses that are going to decide how they perform. And this table really lays out the core trade-offs. Connection-oriented has a pretty high setup delay. That's the whole hello part of the phone call. But in exchange, it's super reliable. Connection-less, on the other hand, has 0 setup delay. You just send the data, but it gives you no guarantees. This difference in setup is absolutely critical. And trust me, it's going to decide our first race. All right, let's get to our first event of the day, the sprint. The challenge is to send a really small message, like a quick chat or a DNS query to look up a website's address. The clock is ticking. One of the sources we looked at for this explainer put it perfectly. For just a tiny little piece of data, any time you spend getting ready feels like an eternity. It is all about getting off those starting blocks as fast as humanly possible. Our connection-oriented racer faces a huge problem right at the start. It's called the handshake penalty. Before it can send even a single bit of useful data, it has to go through this whole setup process, a sort of digital handshake to establish the connection first. And get this, a typical handshake might take around 100 milliseconds. Now, you might be thinking 100 milliseconds? That's nothing. But in the world of computer networking, oh man, that is a lifetime. And here is the real kicker. The actual time to send that small message? Maybe 1 millisecond. So think about that. Our connection-oriented racer spent 100 milliseconds preparing for a race that only takes 1 millisecond to actually run. The overhead is just massive. So the winner of the sprint, and it is not even close, is the connectionless service. It wins by a landslide because it just completely skips that 100 millisecond handshake penalty. It just puts the data on the wire and boom, it's gone. For small messages, there's just no contest. But hold on, the competition isn't over yet. Now it's time for the main event, the marathon. Here, we're sending a large file, like a full-length movie. And as we're about to see, the rules of the race are about to change completely. The key concept that just flips the whole script is something called amortization. It sounds fancy, but it's just a way of saying you're spreading out a big one-time upfront cost over a very long period, which makes that initial cost seem way, way smaller in the grand scheme of things. Let's just visualize this for a second. In the sprint, right, that setup cost, this big bar here, was gigantic compared to the tiny little data transfer time. It basically was the entire race. But now look what happens in the marathon.
That same 100 millisecond setup cost is now just this tiny, tiny little sliver compared to the 10+ minutes of data transfer time. It's been amortized to the point where it's almost negligible. It practically disappears.
So, with its biggest weakness now basically gone, connection-oriented starts to show some serious strengths. Because the path is set up just once at the beginning, routers don't have to think hard about where to send each of the thousands of packets. It's just a pre-planned, super efficient, and really reliable journey. So, after two very different events, who is the overall champion in this race against delay? All right, let's go to the final scorecard. For small messages, connectionless is the undisputed winner because it avoids that killer handshake penalty. But for large messages, the connection-oriented approach becomes incredibly efficient. Its setup cost vanishes into the background, and its built-in reliability is a huge bonus. And that, right there, is the single most important takeaway from all of this. There is no one fastest way to send data. The winner of the race against delay changes completely depending on what you're trying to send. It's all about context. It makes you think, doesn't it? That quick, instant chat message you just sent is relying on a totally different strategy than the movie you buffer for a moment before it plays smoothly for 2 hours. 2 different races, 2 different winners, and it's all happening all the time right inside your devices.